Next up, we have András Strácz. He's our product owner for our new product, Plexus, and he's also going to talk a little bit about the chemicalize.org app for Android as well.
Okay, thank you, John. Before we get to this Plexus thing everybody's talking about, I want to show you what's new with chemicalize.org. So let's start that. So when we describe chemicalize.org nowadays, it's mainly about these three things: content discovery, utility, and UI. So what do I mean by content discovery? So chemicalize.org is pretty much a crowdsourced database, because when our users visit web pages or PDF documents using the tools on the website, then basically they contribute to a large database. Compared to last year, this database grew by 25%, and our number of users went up by 80%, which roughly translates to a very large, very fresh, and very useful database. But just to see actually how useful this database is, recently we submitted it to phys-chem, and one of the nice things that we realized was that roughly 25% of the database is brand new stuff there. And if you follow this URL, then you can actually work with this data set and use all of the phys-chem tools on it. Another nice thing that we realized recently is that just since 2012, we got 40 or more citations according to Google Scholar. And this excludes all of the software reviews and everything like that. So these are real publications where they use either the content or the tools on the website. As far as utility goes, with Chris Southon, who has a poster outside and has copies of it, we set out on a task to just publish how useful we think this tool is. And I just have here a few quotes that show that we found, or we can prove that this demonstrates a very good utility for users, because chemicalize.org works very, very well with other open tools on the web. All of this, of course, is built on ChemAxon technology, including document-to-structure, JChem search, so they come with the extra flexibility that our underlying toolkits provide. Now let's switch on to the user interface. So I'm sure many of you have already seen chemicalize.org. If not, I will have a short demo in a few minutes. But I just want to quote another publication, actually a software review that was published in JSIM last year by Matt Swain. And what he says is that he finds this intuitive interface quite good and easy to work with, and it's refreshing to find something like this in the world of chemistry. Okay, so now the juicy bits. So when we're looking at the analytics on chemicalize.org, we see that, as I mentioned, the traffic grew by close to 80%. And the nice thing is that mobile traffic appeared, and actually it's close to 10% now. It's growing by roughly 1% every month. Now, chemicalize.org is a prototype project for ChemAxon, so we also want to keep experimenting, and this feels just like the next natural step to do that. So we started to get into this app business. Now, why are apps good? So they bring a certain native feel to whatever you're doing on them. They also unlock new features on your phone, such as working with the camera on the microphone. And they also have some interesting performance characteristics that make it useful for development. Now, we had an easy task for the first step, because since last year, chemicalize.org has been working perfectly on mobile phones in the browser, be that an iPhone, an Android, or even the latest Windows phones and BlackBerry devices. So let's see what we managed to cook up. So this is going to be a video about the Android app. So here's Chemicalize running in the emulator, because that's the only way I can record a video. I started on my Android 4.0, and here I have the front page. On the front page, I have a quick start guide for all of the major tools on the website and a bunch of starting structures. Please excuse the lack of smoothness. That's the emulator. The actual app is actually very nice to use. So I heard about a structure called resiniferatoxin. Let's see what we have about that. Notice that we had autocomplete, so you don't really have to type the full name. And we'll use this ChemSearch tool to work with that structure. In our database of that 600,000 structures, we found an exact match and a bunch of highly similar structures. So let's just look at the properties of the structure to confirm that this is actually what we wanted to take a look at. On the properties page, we have a bunch of calculations that use our calculator plugins to show certain characterizations of the molecule for medicinal and computational chemists. So once we confirm that this is actually the structure that we want to work with, and we have a bunch of other plugins that are not by default not enabled, but you can play around with them. So once we confirm that this is actually the structure that we want to play with, let's head back to the ChemSearch and see what kind of reading material we have on this structure. This is the database of those 400,000 web pages that our users regularly visit. So for this structure, we had 92 pages that describe it, and this patent, EP23 something, looks like a good document. At the top, we have a ribbon that describes all of the structures in 2D image. And if we click on resiniferatoxin, then it takes us to the exact position of that structure and even highlights it. And if you can tap on it and reach other tools. Of course, the app unlocks all of the other features of chemicalize.org as well, including the document viewer, which lets you work with PDF files as well. The Android app is available in the Play Store, and it's coming soon to iTunes when we resolve our differences with Apple. So just search for Chemicalize in the App Store, and you can play with the application. Now, over the years, we got a few questions from our clients and our friends on, okay, chemicalize.org is nice, but how can I use it? How can I get my own copy? Well, today, I'm happy to announce that we finally have an answer, and that's Plexus. So what is this Plexus thing? It's a new application, it's a new end-user application from ChemAxon for chemists. It's a versatile thing. So from a technology point of view, it's a thin client that is based on web service architecture. It works in your browser, and it's deployable in all scenarios thanks to the web services architecture. So you can run it on your PC, acting as a localhost server, or you can access it through an internal network, use it to connect to your external partners, or even deploy it to the Amazon or Google cloud services. It's also user-friendly, because that's what we want to build. And user-friendliness, particularly in case of Plexus, means that we set out on a quest to come up with a design that brings a consistent and good-looking web application look and feel. You've already seen this with the Instant JChem web client, and you will see more examples of this in the compound registration presentation. One particular aspect of this design is that it brings high visibility to important actions, and it tries to hide the rest. The layout is clear and structured, and it has a fluid design, which means that it works in pretty much every browser, every monitor resolutions that you have, be that a small notebook or a 30-inch Apple Cinema display. All of this combined, plus some other stuff, the user experience should be fast, it should be streamlined, and it should be full of intuitive solutions, so you don't have to learn this application again. And I should point out that Marvin for JavaScript fits perfectly in this. So just a few examples of this style guide. So one of the things that we defined, for example, are these call to action buttons, the most important buttons, where we even gave unique colors to certain kinds of actions. So everything that creates a resource is red. Everything that does something that is potentially long is blue. Everything that modifies a setting or a certain behavior is green. Everything else is white, so that it's there, but it's not too looking important. We also defined how form elements should look like, because where everywhere in the application we have controls for certain behavior, be that basic options or advanced options for searching or enumeration. I will show a few examples of this. We also defined how a toolbar should look like, where most of the features of the application can be accessed. And finally, we also defined how login pages should look like. Again, this is something that you should see in IJC Web Client and the registration system. Last but not least, Plexus is a workflow-oriented discovery tool, as I mentioned. Our current focus is library design, the traditional chemist's library design workflow. This lets us connect most of the ChemAxon tools, but we did this in a modular fashion, so it fits however you work with an application and whatever you discover and need in an application. And I want to stress out that this is actually built for chemists. So we have lots of business analysts and application scientists who help us daily with issues on how to build this application. Okay, so let's get to some demos. One of the first things that you will use in an application is the data table. It's a table view for your data. All of the expected features should be there. And I want to point out a few key features. For example, importing Office documents using document structure, or exporting to JChem for Excel workbooks when you're finished. And I let you judge this, but I think it looks great. And before I forget, we also came up with a way to easily add physical chemical properties and like Lipinski-like filters. So let's see the video. So this is the launch screen of Plexus. At the top, you find a few ways to get your data in the application, but I should point out that it also works with existing JChem-based tables, so you can set that up on the database level as well. Beneath that, you can see all the data that is already connected to Plexus. So if I go to add stuff to my Plexus instance by drawing molecules, then I can start using Marvin for JavaScript. And with the web services backend, we can also unlock the features of Marvin for JavaScript that actually need a web services component. I can also define a few properties. Imagine this is where your raw measurement data would go in if you do it at my end. But for now, we'll stick to uploading a file. And I can just do the fancy thing and drag my EP2377 something patent. This is sped up for demo purposes. So now I have a structure table, a brand new structure table with 1,200 molecules in it. As you can see, all of the properties that document to structure provide, for example, the actual text by which the molecule was imported, the page number, the context, as in a few words around the hit, are all still there. Okay, let's see the next one. And that is library enumeration. So you got your data in Plexus, and now you want to play around with it. Well, one thing we have integrated is Markush enumeration. Now, traditionally, Markush enumeration is done via the Marvin sketch panel, which is kind of difficult to use for Markush purposes because you don't really fit in a single canvas. So we designed a new Markush editing interface where different pieces of the Markush structure can be edited differently, and they are presented in a nice table. This works very well with small and large libraries. And also on this page, we put in a library analyzer that shows you interactive a preview of your enumerated structures, library size, and things like that. So here's my 1,200 structures, and this structure 85 is looking good. So I right-click on it, and I go to enumerate structures. The structure that we selected is a traditional molecule, so we put it in the scaffold box. Beneath that, we have a way to add R groups and our preview, which already shows one structure. So first, let's make a few edits to this scaffold. First of all, let's remove that chlorine ion and put a position variation bond on that benzene ring, because that's a good reactive spot. Notice that we modified Marvin sketch a little bit to bring the Markush features right in there when you need them. Also, let's put an R2 there, and a homology group on top of the benzene ring. Once we have that, we hit edit, and our interactive preview will update on what we know about this structure. Notice that now we have R1 and R2 rows pre-filled, and our interactive preview shows 3 structures because the position variation bond allows 3 different enumerations of this. Okay, so now let's start adding our group definitions. I'm cheating and I'm copying from a notepad, but let's add a few fragments that we want to play around with. And again, a few fragments for R2. All the way through, our interactive preview kept updating. So what you should see now is we have an estimated library size of 18. This doesn't count homology groups yet. So let's just turn that on to make sure that, and we have help for some of the advanced options in case you need it. This might be more important for what handle valence error means, but it shouldn't be an issue. So let's hit enumerate, choose where to save it. This will create a new structure table that we can permanently work with. Once the enumeration finishes, we have close to 700 new structures, and this is something that we can now start working with. So now let's get to structure searching. So you enumerated your structures, and you want to start filtering out the stuff that you don't need. So we have full coverage of the JChem search options. Also to make sure that JChem search works the way you want it to work, with different representation of structures. We also put in a default standardizer configuration that should be good enough for the first use. And we have included Marvin for JavaScript here as well. And we have reworked the user interface a little bit to make it easy to use in the everyday scenario. So basically, we split the basic and advanced search options. So we have a structure table with those 700 structures. First, let's start characterizing it. So in this right-click menu, we have predefined a bunch of physical-chemical properties and a few Lipinski-like filters. And at the bottom, we still have the possibility to use just regular chemical terms to come up with any descriptor for the structure. So let's add C-log-P and let's add TPSA. And then we can get to searching and filtering. So I hit search. This is that reworked user interface. On the left, you have Marvin for JavaScript, and on the right, you have your substructure search options. All the other options, advanced options, are still available. They are just one click away with help if you need it. So for now, let's do a search with piperidine. And let's do a filter on our new properties. Make sure log-P is less than 3, and make sure TPSA is less than 100. Just some good metrics from the Lipinski rule, I think. So once we hit search, it's actually this fast. This is not edited. Then we have 3 structures, and this is something that we can start actively looking into. So now comes the details view. Details view shows everything we know about the structure. It basically calls upon the calculator plugins, and that might mean structures with incremental result values, that might mean property lists, that might mean charts. So basically all the stuff that you know in the Marvin Sketch calculations menu. Also, as an extra, we have made it easy to access virtual screening tools in the structure search feature by integrating 2 extra fingerprints that let you do structural similarity and pharmacophore similarity searching based on ECFP and FCFP. These are pretty good when you want to do some basic close analog searching or look for scaffold hopping targets. So here's my finished search with those 3 structures. I right-click, view details. Here we have one single box for every single calculation. In the future, we will introduce, of course, customization option and more ways to characterize your structures. And as I mentioned, all of the options that you know from Marvin Sketch are available here. to configure how log D is calculated. Once I get acquainted with the different calculation methods, I can, for example, choose to use this VG method, and I hit update, and then I get a new chart. And of course, here I also have ways to edit my structure. So if I realize that something is wrong with the structure and I just delete it, then I can either modify the structure or in one step modify it, save it as a new structure in my database, and then I get the properties of that. For now, let's head back to the search interface where I will show how to use this similarity search feature. So I choose similarity search from the search type drop-down, and then I select pharmacophore similarity, and then I paste a known active compound just to see how it works. And because we have a limited Markush dataset, I set the threshold to something low. So here, in a matter of seconds, I got a new dataset with 12 structures. We can call these similar in some sense to the known active compound. So let's just send it off to colleagues. In the export menu, I select JChem for Excel workbook. And once I made sure that I export all of those 12 structures, I have my JChem for Excel workbook. To sum up, the current coverage of tools in Plexus include these tools: document to structure to handle PDFs and Office documents, JChem base to do the database thingy, standardizer to make sure that JChem search works no matter how you represent your structures, Markush enumeration for the first bit of that library design process, calculator plugins to help you characterize your structures, screening for similarity searching, and of course Marvin Applet and Marvin JavaScript are in there. And as for the roadmap, as for what's coming in 6.1 and 6.2, we're working on project and user management by employing the security framework in the underlying web services product. Of course, customization for the details view and more information sources such as an array of databases. Then we're also looking into adding more of the ChemAxon tools for discovery, such as virtual synthesis with Reactor, clustering with JCluster, data visualization in the charts, that's going to be a big one, and of course some useful stuff like relation data handling and an actual desktop installer, because for now we only have the server installer, and this is something that you can download and try out today. The installer is up on chemaxon.com/download. And we also have a couple of demo sites, for example, plexus.chemaxon.com, where you can try all this out. I should also mention that we have usability testing or user testing in the demo room, where you can try out the application, so we get some feedback on how well it actually performs. And I guess tomorrow there'll be a presentation about this web services component, another new product that we have, the brand new version of JChem Web Services, which allows us to do everything that you saw here. And that's it.
So from a strategic point of view, how can we solve this Plexus functionality if we compare this with the Instant JChem web client? Can you comment on that, please?
Well, we have two answers to that. One is that in the close future, we are looking into integrating these two products. So as you saw, Instant JChem web client is a way for you to access your expert database manager application throughout a web client, that is, perform queries and look at the data that you have in your relational data tree. But Plexus focuses on the discovery tools. We've been only working on this for like a couple of months, so we've only gotten this far, but in the future you should see more features in both and an integration.
Does that mean in the long-term future there will be just one product?
Yes.
Okay.
That's the goal.
András, that ability to extract a piece of text tag either side of the name seems very powerful. What's the flexibility there? Can you extract a whole sentence either side or tune it?
I think for the current version, we only have this basic support which looks at 5 words on each side of the hit. But this is basically a feature of document to structure. So this is available in JChem for Excel, Marvin View, Instant JChem, and if you need customization, then I guess you should talk to Daniel. He is developing this toolkit for us.
Yeah, so in document to structure, you can configure how many words you want on both sides of the text. In Plexus, I don't know, you could use this option, but I don't know if you can make user options that are specific to each user.
Sure, we can.
Yeah, okay.
We'll find a way.
We'll
Thanks.
be there.
So you didn't have a 3D visualization on your list. Is that because it's not been developed yet, or it's not planned to be integrated?
It's a separate project, but of course we're looking into integration of that as well. It's coming when we have, for example, things like clustering and other calculators, for example, molecular dynamics, conformers, things like that. So it will make sense when we get to that point.